So for number 1, it asks us which satellite has the greatest speed, and the one with the greatest speed is going to have the greatest kinetic energy and the least potential energy, because kinetic energy represents motion, and someone who's moving would have a greater speed than someone who's just sitting down on a chair. So the radius is kind of like the height in a way. Like the higher you are from the floor, the less kinetic energy you're going to have and the greater potential energy. The object is kind of like that floor in a way. The farther you are from that object, the less kinetic energy you're going to have. So in order to find the one with the greatest speed, it's going to be the one that's not far, the least farthest from that object. So it's the one with half the radius and the mass. So number 2, it asks which of the following quantities increases as the asteroid moves from point P in order to point Q. So at point P, it's kind of really close, and at point Q, it's kind of far. So the potential energy number increases. 3 asks for the weight on a different planet that has twice the mass and the radius. So let's say Earth's Fg, or weight's going to equal 8, and if you multiply the mass by 2, so like the mass in the other was 8, so you'd have 16 over 2 squared, which is 4, and 16 divided by 4 is 4, so 8 divided by 2 is 4, so 800 divided by 2 is 400. So that's how you do 3, because the weight would just become half, and you can see that as you like plug in numbers. Okay, so for number 5, it asks us which of the following would be true, and it's A and B, because on Earth you'll experience twice the gravitational force, because weight is equal to the force of gravity. So if you have twice, which is also mg, so if you have like 2 times m, you're gonna have twice the gravitational force. And also because on the moon it would have twice the weight of y, because if it has Earth, it'll have twice the weight on the moon. So for number 6, it asks which of the following quantities must have the same magnitude for both spheres, and it's kinetic energy, because they have equal densities, and in order to find density, the formula is m divided by v. So even if they have different masses, like the velocity for one might be higher than the other, and the kinetic energy relies on both of those. So for number 7, it says an object has a weight of w when it's on the surface of a planet of radius r. What will happen to the gravitational force on the object after it's been moved a distance of 4r away from the center? So since it's 1 over 4 times r squared, so like 4 squared would be 16, it would be 1/16. So for number 8, it asks on the surface of the new planet, a person who weighs 500 newtons on Earth would experience a gravitational force of, and it's 250 because you could plug in numbers, and you see if the Earth had a mass of 200 and you would a radius of 10, it would become 2, and if the new planet had like twice the mass and the radius, 400 divided by 400 is 1, so 2 divided by 1 2 divided by 2 is 1. So you would get 250 because 500 divided by 2 is 250. And for 9, it asks which of the following statements is true about the periods of the objects on planet X compared to the periods on Earth. So the period of the mass on the spring is shorter because it's twice the mass, and that only affects the spring, not the pendulum, since the formula is that. And the pendulum would stay the same because it has the same diameter. For number 10, it asks, what's the radius of the satellite's orbit? So we know that gravity is the centripetal force, and then we could use that to find r. So we know that a mass cancels out, and you have gm2 equals v squared divided by r squared. So you cross multiply. gm2 r equals r2 v squared divided by v squared multiplied by 1 over r. So you'd get that r equals gm over v squared, and that's actually choice B. So yay. And so for number 11 asks for as the satellite moves from point X to point Y, which of the following is true about its speed and angular momentum. So momentum is m1 and v1. The mass is not going to change, but since it's moving to Y, it'll have like a less radius because it's closer to Y. So the speed's going to increase. So the question asks for the gravitational field strength at the surface of the new planet is when it's equal to that of the Earth if the radius of the new planet is equal to blah. So I got B for this because first I solved for the force of gravity, and that's Fg of both planet Earth and the new planet or whatever. And then you set them equal to each other because the question says that they're equal. And then you would solve for the radius. And you get that r equals 2 times re, which is choice B. So for question 13, it asks how the accelerations are related if r2 equals 2r1. And I did this by doing gm1 m2 is equal to mv squared divided by r, since they have a centripetal force, and then that you get that the centripetal acceleration, since it's asking for it shows like it's asking for the accelerations, so that's v squared divided by r, and you get that v squared divided by r is equal to gm1 over r squared. So the question's testing the radius, so everything like on the numerator stays constant. So I made r2 have a radius of 4, so 4 squared 16, 16 divided by 16 is 1, and r2 have a radius of 1, so 2 squared is r1 have a radius of 2, so 2 squared is 4, 16 divided by 4 is 4, so a2 is equal to a1 divided by 4. And for 15, it asks the magnitude of the force exerted by the satellite on the Earth, but it's going to be F1 is equal to F2 because of Newton's third law. And then for question 16, it says that a newly discovered planet has twice the mass of Earth, but the acceleration due to gravity on the new planet's surface is exactly the same as the acceleration due to gravity on the Earth's surface. And it asks you what the new radius of Earth is. So for this one, you would solve for the Fg of both of them. And for Earth, it's just g equals m divided by r squared. And for the new planets, g equals 2m divided by r squared. So then you would set them equal to the same value. So you can set them equal to 4, and 16 divided by 4 is going to equal 4. So 16 times 2 is 32 divided by what is going to equal 4. So the radius would be here. It's supposed to say r squared. So r squared times 4 is going to equal 32. You do 32 divided by 4, and you get 8. And 8 equals r squared, and you take the square root. R equals radical 8, and then you plug into the original question, and you see which one of the choices gives you radical 8, which is 2.828, and that's radical 2 times 2.